These are the Section 7.3 notes. So today we're going to talk about raising a power to a power. This means you're going to have numbers or letters with exponents on the inside of parentheses with another exponent on the outside. In order to do this, we're going to distribute the exponent into the parentheses. Now remember that distributing just means you're going to multiply. So you're going to multiply the inside exponents with the outside exponent. So for this first one, I'm going to distribute this little 2 to the little 4 that's on the inside. So I keep the base the same, so 5 stays, and then 4 times 2 is 8. So this becomes 5 to the 8th power. Now I can plug that into my calculator and get my final answer, which is 390,625. This next problem shows that it works the same way if you have fractions or even just variables. So if I distribute this, in order to multiply a fraction, I want to make this other exponent a fraction. So 3 as a fraction is just 3 over 1. So when I multiply, I'm going to keep the base the same. I'm going to multiply straight across. So 3 times 3 is 9 over 2 times 1 is 2. So my final answer is just going to be a to the 9/12. You do want to keep exponents as improper fractions. So now, this next one, I have a number as a base and a letter as a base. I'm going to distribute this outside exponent to both exponents on the inside. So this 4 now has an exponent of 2 times 3, which is 6. The x has an exponent of negative 5 times 3, which is negative 15. Now, am I allowed to have a negative 15 as an exponent? No. So I'm going to take the base that the negative 15 is attached to, and I'm going to move it to the bottom of the fraction to make it a positive exponent. The 4 to the 6th power can stay on the top. Now to simplify this even further, I can actually perform the 4 to the 6th power on the calculator. So 4 to the 6th power is 4,096. So it's going to be 4,096 over x to the 15th power. Now we go to the second row. Now we're multiplying fractions times fractions, which is actually pretty easy because remember, you're just multiplying the top numbers and then the bottom numbers. So for this first base of x, on the top I have 2 times 1, which is 2, over 5 times 2, which is 10. For the y, I have 2 times 1, which is 2, over 3 times 2, which is 6. So now I can actually simplify these down. So 2/10, what goes into 2 and 10? Well, 2, so I can divide each one by 2. So 2 divided by 2 is 1, 10 divided by 2 is 5. So that can simplify down to 1/5. This next one, I have 2/6, which again, you can divide each one by 2 and end up with 1/3. So your final answer should be x to the 1/5, y to the 1/3. This next section has part of the problem not in parentheses with the 8mn in parentheses. The first thing you're going to do is the parentheses part. So you are going to distribute this 1/2 to all of the parts on the inside. Now, what exponent is here that's invisible for all these? It's 1. So that's 8 to the 1 power, m to the 1 power, and n to the 1 power. So when I multiply, I'm going to end up with, well, this all stays, so 4m to the 1/2 n. This gets out of the parentheses, so 8. Then I multiply. 1 times 1/2 is 1/2. M will also be 1 times 1/2, which is 1/2. And n is 1 times 1/2, which is 1/2. So that's my first step. Just making sure to get rid of the parentheses by distributing in the 1/2 that was on the outside. Now I have to simplify. So to do this, I'm going to take the numbers. So I have 4 as a base, and I have 8 1/2. So there's multiplication going on here, even though there's no sign in between. So I can use my calculator and do 4 times 8 to the 1/2, and I get 11.31. Then I go to the m's. So I have m to the 1/2 times m to the 1/2. Now remember, if you have the same base and you're multiplying, you're actually going to add these exponents together. So 1/2 plus 1/2 will give you m to the first power. Now for the n's, I have n, again there's nothing here, so it's going to be an invisible 1, so n to the first power and n to the 1/2 power. If I add those exponents together, I'll get n to the 3/2 power, or 1 and 1/2. But remember, I want to write it as an improper fraction, 3/2. So I have the numbers, I have the m's, and I have the n's. So now I just put them back together. So my final answer will be 11.31, m to the first, n to the 3/2. So I kind of split it up and did each part by itself and then put it back together. I'm going to use that same method on this next problem. Now I have 2 parentheses. So for this first one, what I'm going to do is I'm going to go through everything that doesn't have an exponent and put a little 1 as an exponent, just so I remember that yes, it does have an exponent, it's just invisible. So now I'm going to take this 4 and I'm going to distribute it into this parenthesis. So that'll become 3 to the 4th, because 1 times 4 is 4. C, well, again, going to make this a fraction. 5 times 4 is 20. 2 times 1 is 2. Now I go to this next parenthesis. I'm going to distribute this 3 into all 3. So 5, 1 times 3 is 3, so 5 to the 3rd. C to the 3rd, because 1 times 3 is 3. And d to the -6th. So as I'm looking through here, this fraction, 20/2, can be simplified. 20 divided by 2 is just going to be 10. So as I rewrite everything else, I just simplify the c right here. So now it's c to the 10th power. Now again, I'm going to take the numbers. So 3 to the 4th times 5 to the 3rd. And I'm going to plug this straight into my calculator. And I will get 10,125. Then I take the letters. So my first letter is C. So I have C to the 10th times C to the 3rd. Again, I have to add these together because I'm multiplying. So I have C to the 10 plus 3 is 13th. And then my D is d to the -6. It doesn't have anything to add with, so it just stays. Now I have to put this back together, so it's going to be 10,125, c to the 13th, d to the -6th. Now, can I have a negative exponent? No. So you're going to take this and you're going to move it to the bottom. So I'm going to make a fraction and put d to the +6 on the bottom and erase this from the top. So your final answer is 10,125 c to the 13th over d to the 6th. Okay.